Hello, CIS41D. In this video, I'm going to re-record for our lecture that was covered in the last week. The reason why is that the video that we previously recorded in class was interrupted due to Zoom app. So in this video, I'm going to cover the unit that we covered in class. So in this week, we talk about Chapter 8, which is implementing incident response plan and the practices in IRP, along with forensic procedures. So the first part of the notes, it talks about incident response plan, what it entails, and the requirement of response plan. For the government agency, we have to follow Federal Information Security Management Act, which is FISMA. And the requirements are listed here, which was not included in the chapter, but this was something that I supplemented based on FISMA documentation. So the requirements can include continuous monitoring, which requires the company to monitor and detect incidents. That means that we have to take a look at the services and the applications across the network, looking at potential unauthorized installations or any potential threats. The second requirement entails security assessment and authorization. That means that we have to do regular security assessment, meeting the compliance requirement in security control, access management, along with operations for all our network systems. The third requirement include risk assessment and looking at the vulnerability. So we have to perform scans along with assessing any kind of potential attacks that might occur or currently impacting the organization. And with that, we have to prioritize mitigation efforts, meaning that we have to take a look at the critical impact and addressing that first. Then we have to include encryption. By default, encryption is required by FISMA for all data that is sensitive, whether we have data in motion, data that comes into the network and leaving the network, along with data that's being accessed within our systems for operations. So encryption is required for all sensitive data, such as personal health data, along with any identifiable data. The next requirement would include audit and accountability. So if the organization is affiliated with a third party, a contractor, a partner, any kind of business that works with the organization, we have to perform annual audit, and that's a requirement for FISMA. And lastly, we need to make sure that NIST 853 compliance is fulfilled. We would refer to the documentation from NIST 853 to improve our security in the organization. So in the assignment, we want to include those points for the first question, which asks you federal agencies and contractors, what are the requirements for the incident response practice? We mentioned that we want to make sure that we continue to monitor our network and our services and applications, along with conducting security assessment, identify vulnerability and potential impacts for cyber attacks, and prioritize mitigation effort, encrypting sensitive data, along with making sure that our third-party partners and affiliates meet FISMA standards, and this is done with the annual audit. And lastly, fulfill NIST 853 compliance, which making sure that the security practices and implementations is in place for the organization, and we refer to the documentation for that. Question 2. What should be considered when developing an incident response plan? So in the notes, it mentioned that it's important that we make sure that we have team members. That would include incident responder and people who are affiliated with the team, along with your executive managers and team leaders. And we must have an escalation process. This allows us to make sure that since we come across the incident to the time that we report the incidents and we respond to the incidents, we have to have proper procedures. And the involvement for incident response plan would include stakeholders, your legal team or legal counsel, and it's important that we include human resource in the case that we deal with internal threats, and that would address any kind of corrective actions or dismissal in the organization. So our incident response plan, before we develop it, we have to make sure that we have the team in place, along with making sure that we communicate with our stakeholders, legal partners, and human resource to develop the incident response plan. Now, in the notes, it mentioned that you should refer to United States Computer Emergency Readiness Team US CERT for reporting purposes, and then I included the link here. In this link, you'll be able to find more information about how you would be able to respond to threats and the proper procedure in reporting in the case you come across attacks and potential threats. For NIST SP 861, this publication includes Computer Security Incidents Handling Guide, which is a guidance to how you can respond to an incident and plan for incidents for federal agencies and your organizations in general. So to start, if you don't know how to approach an incident response plan, you would refer to NIST SP 861. The next part here address our question 2, which we mentioned on how we would be able to build the team. There are guidance for United States with NIST SP 861 documentation. And for the UK, you would refer to National Cybersecurity Center, NCSC. And you can see the link that's included in the notes. For events classifications, how can we identify or detect events? We would use intrusion detection system data, things that are detected by the IDS or security appliance, along with using SIEM, Security Incident and Event Monitoring System. This is going to help you build out some of your operational data knowledge on what would be threats coming into your network and systems. And then we can also refer to Common Attack Pattern Enumeration and Classification, your CAPEC. This is provided by the Homeland Security Agency, and it includes the attack patterns that you would commonly see. They document all the attack patterns from distributed denial of service to various attacks. So you can refer to Mitre website for CAPEC. So in the next question, it asks you, how can we identify malicious events for classification in IRP? We want to use data from intrusion detection system and security incidents event monitoring. We also want to manually detect information with effective training. So your specialist, security analyst, incident responder. The first incident responder would go through security awareness trainings, so that way they are prepared for manual detection. We should also interview service desk technicians and first responder for information and threat incidents. And we would refer to Common Attack Pattern Enumeration and Classification database, which provides us with attack patterns and threats that are commonly found in the industry. In the next question, it asks you, why is business impact analysis important in IRP development? Based on statistics, the organization that don't have business impact analysis eventually will suffer in losses because they don't have a plan in place on their critical systems. BIA, if you recall from CS27, it addresses the system outages time and the recovery time for those systems for business operation. So the answer for this is it helps identify the impact levels of the critical system for the daily operations. So for example, if you have servers for retailers, transactional servers, databases, web servers, those are critical systems for the online retail business. So we have to identify how those systems can be impacted in the cases of attacks or even internal threats or data leakage. And with that, we have to come up with the amount of maximum allowable outages, the amount of time that can be down, and the amount of time that we need to recover the systems, making sure that we address the losses and be able to mitigate some of the loss for the business in that plan. And your BIA information is provided on page 2 of your notes. It addressed the mission mission essential services and the importance of that, and we will cover BIA more in detail in a later chapter. So in incident response plan, there are phases that we would go through, starting with preparation. In preparation, we want to make sure that we build out our security foundation. We're patching, we're making sure that we meet the baseline for security requirement or better. With that, we would then be able to develop out our incident response plan, because if you don't have security in place, there's no point in building out incident response plan. So in the next question, we want to go over the tasks to be completed in preparing for IRP and why are we doing these tasks. The first task is to perform risk assessment, and this includes scanning, interviewing, and looking at the risks that the company is currently facing internally and externally with our critical systems. Second, we want to harden host systems. That means we want to patch, install anti-malware, making sure that we have proper configurations for security measures. So hardening system is going to give us the overlapping security needs. Third, we want to secure networks. We want to make sure that our network is properly segmented, protected with filtering, blacklisting, and whitelisting, along with adding the proper security appliances and its configuration to block and deny necessary patterns for our attacks. We want to deploy anti-malware, and we want to use anti-malware live so that way we can detect threats. The majority of the incidents that's coming into the network will be malware, so we want to make sure that we're prepared for things like ransomware or any kind of malware that would impact our systems and cause outages. Lastly, we want to implement user awareness training. This will help our employees recognize threats, internal threats, or threats that are coming into our systems. So regular user awareness training is important. The reason why we implemented these tasks is to make sure that we help strengthen the current security posture for the organization while providing improvement information for the incident response plan. So the security foundation is important. Without it, we would not have a baseline to build upon. Now, when we scan or when we look at result from our systems for security, we sometimes would see results in various types, from false positive to false negative, or true positive to true negative. So for question 6, it asks you to identify the types of security results based on the given scenario. A, the anti-malware application identifies the benign download is malicious, and this is false positive. So when something is overly sensitive, where it looks at anything can be malicious, that will be false positive. And a lot of the systems tend to be false positive, which is a little bit more on the panicky side, but that is better than false negative, which is what you see in question 6B. B, network intrusion detection system did not detect denial of service attack. If it's not able to detect an attack, that is false negative. That means that it would let many attacks to bypass, and this is what we don't want. So when you're looking at tools and security appliance to implement into the network or your infrastructure, you need to make sure that it is not false positive, a false negative. False positive is better than false negative in that it does detect something that is benign, but it would tag it or notify you as something could be potentially malicious. In that, you would allow it to bypass. However, if you have something false negative, it would not be able to detect at all. So that means that your attack can bypass. 6C, an attack was detected and blocked by firewall, and this is true positive. That means that the firewall is doing its job. It's able to detect and block an attack. So you want your system to be true positive. And this is the best in the scenario for the result in your system. 6D, the downloaded file from a suspicious website was not quarantined because it does not contain malware. And this is true negative. Even though it's coming from a suspicious website, it is not malicious, so it's not quarantined. So that it is doing its job, and it is true negative because it does not need to quarantine. So in the best case scenario, we want to have true positive and true negative versus false positive and false negative. Question 7. What should you do when a ransomware has entered the network and it is spreading fast? So when you have a malware impact, you need to, number one, quickly isolate the affected system physically and that or network segment. So that means that we have to disconnect the system and the network. And we need to perform the scan to contain the malware and report the incident. And we can definitely isolate the system and scan. We need to make sure that anti-malware is on the system regardless. So after the incident, we can use a website like VirusTotal to check its definition in the case that if your anti-malware is not able to find the signature or behavior of the malware. Or you can also use anti-malware database from various providers to determine the eradication approaches. Some malware can be more malicious than others, so we want to make sure that we are up to date. If your system is up to date, it's able to detect and quarantine. If it's not, right, in the case of ransomware, it will encrypt everything where it would be harder for you to decrypt. And so, but with the behavior of the ransomware, your system should be able to detect that as a ransomware. And if it doesn't, you have to be able to use an external source to determine what kind of ransomware that would be. You can also report it to the website. There are various websites that would allow you to report certain malicious file, such as VirusTotal. So it will be able to tell you the signature or the behavior of the malware and what kind that is. So in the face of the detection, which is on page 4, it talks about how we would be able to look at attacks and different types of entry point where we would have malicious or threats coming in, such as through email, through downloads, through unauthorized software, denial of service attack, And in the case of physical theft, like theft of equipment, impersonation, there are many different types of attack from logical to physical aspect. So we want to make sure that we prepare for those type of attacks and threats in our incident response. And so your intrusion detection prevention system or intrusion detection system, your SIEM and anti-malware and some of the software and DLP are some of the solutions that you need to include in your overall security plan. Your result types are listed under the analysis phase, and this what we had gone over with the scenario with false positive, false negative, true positive, and true negatives. And in the next stage of incident response would be containment. And we touch on how malware attacks can be spreading fast. Or in the case of if you have worm or Trojan, we want to make sure that we contain, isolate. And most of the systems is going to quarantine and not remove the file because those are system files are impacted with the malware. So we want to make sure that our anti-malware is up to date. Now, for denial of service attack, there are different approaches on how we can handle distributed or denial of service attack. So in the next question, it asks you, what should you do to contain a DDoS attack? It's recommended that you use remote trigger black hole, your RTBH. This is going to allow you to divert traffic into an area that would be able to contain the attack. Now, your attack patterns, the rules should be set with your firewall or your security appliance. So when it's looking at, like 50 or more packets coming in from the same source or even a group of sources, because they can use bots in order to do distributed denial of service attack, we want to make sure that that gets transferred into an area of the network that's considered the remote trigger black hole. That's going to contain it instead of directly have it transferred to the attack target. So when in that case, you would need to set route and be able to create remote trigger black hole. And another area that you can look at is to use internet service provider. They do have mitigation services that would allow you to contain the distributed denial of service attack. And once that happens, we want to be able to escalate the incident. So we want to report the incident. And in distributed denial of service attack, as it is a formal attack, we can report it to law enforcement and other agencies to be able to track in the case that the attack would cause loss and damages. And so that way, if the company is using cybersecurity insurance, this is important that you report the incident to the law enforcement as well. Number 9, what documentation reference is used in eradication and recovery procedures? We want, in the incident response plan, it's really addressing how we respond to the incidents in various threats and scenarios. But we also want to look at the disaster recovery plan, which is your DRP. This is going to allow us to understand how we can move forward and recover after the incident. So the DRP provides implementation guides, configuration guides, and hardening checklists. So when you build out the DRP, we want to make sure that we have the proper procedures for how we would configure our systems and harden our system when we rebuild the system. Now, many companies would use databases to store images and configuration for the existing systems, and we need to make sure that those databases get backed up. And so in the case of an incident, and if we have lost a certain system, we need to rebuild it, we would refer to the inventory or the database to be able to recover and rebuild the system. So it when you look at the incident response plan, the post of incident response plan would also include disaster recovery plan. Now, eradication and recovery information is going to be on page 6. We also need to put down the lesson learned in the documentation process. For after we respond to an incident, it's important that we document this so that way we can improve from it. In the case that if we come across it again, we would be able to refer to that and be able to do the same procedures or use improved procedures. So that means that we have to build out something that's called the playbook. And in organization, they would have multiple playbooks for different type of scenarios. In the case of if you come across malware or data leak or social engineering and so on. So your playbooks include how we would be able to respond or the procedures on how we would have corrective actions in the case that we come across these scenarios. And so the resource that you want to refer to is going to be NIST SP 861, as we mentioned before, which gives you on how you can handle multiple incidents. And these are just the guidelines for you to follow. So they give you the ground on how you can build your IRP. Now, not all incidents can be automated in response. In the case if you need to have manual response, we would refer to configuration management database, which brings us to the next question. From question number 10, what should be included in the manual or playbook for non-automated incident response? We want to use configuration management database, your CMDB. We want to refer to our network diagrams. That's going to give you the layout, the network, so you can have better understanding on how attacks can come in from a certain entry point. We want to include escalation procedures on who we need to contact and how it's going to get escalated for reporting purposes. And then we also need to have a contact list of the people who are going to be handling incidents and the people we need to contact for management purposes, for decisions. 11, describe the content of a run book and when is it used. Run book is different than playbook. As we mentioned before, the playbook includes strategies on how we handle the incidents in various ways for different type of incidents. A run book would contain common scenario and documentation steps on how to contain and recover from an incident, but in a manual response, not an automated, in an automated response, not a manual response. So the playbook is used in a manual response, whereas the runbook is used in an automated response. It does not contain multiple decision points, so you don't have decision tree that's included in the runbook. Whereas in the playbook, you would have the decision tree on if this happens, then this is going to take place. Where the run book doesn't have that decision point that's integrated in the SOAR. That's known as security orchestration and response. And so to define what that is, the purpose of SOAR is used to advance detection and to identify threats. And it really is a way on how we would manage the response to various threats by looking at indicator and how we would be able to utilize the data in advanced detection. So SOAR is going to give us an overall understanding of specific threats and how to be able to manage the response to those threats at the advanced level. So in incident, how do we establish a communication plan? And it's important that we document the timeline in our communication plan. The majority of the time, the incident is failed in response is due to the lack of communication or the delay of communication. So it's important that we establish the rules of engagement for external incidents reporting. In the case that we need to report to law enforcement or third party, if you have security service that is outsourced, and then outside or external requirement. We want to also include investigations for a legal response. Investigation can take time, as sometimes that you would need legal requirement or court order to be able to perform forensic or obtain data. And then the majority of incident response would require forensic process. So your forensic tools and techniques to gather the artifacts for the evidence of the incident is important. So these are some of the things that we need to make sure that is in place in the incidents communication plan. And in the next part of the notes, it talks about forensic, which is part of your incidents response plan. So you can go through, and I think CIS41D talks about the forensic process, but we want to make sure that we understand the forensic. Digital forensic require a lot of various investigations, including legal investigations. So that means that you have to have corporations from various entity. Sometimes that needs consent from people in order to access their data and resources. And investigation is often performed by the internal staff. And if it is outsourced, it needs to make sure that the company is have the agreement that's signed and permissions that's allowed. So for forensic techniques and integration, you would use NIST guidance SP 886. This documentation gives you the layout on how you can perform the forensic process. So it includes 4 phases. Number 1, we need to collect data. And data collection would entail examining disk, but before we examine the disk, we have to create the image of the disk or the system. Sometimes you need to do live analysis where you need to collect the system while it's running. For example, the server doesn't shut off. And so in the case to perform forensic, we want to capture the image, but if you perform the analysis on the image, that's considered a dead analysis. So when we do a live analysis, keep in mind that your tools does impact and changes the state of the system. So making sure that we document that process and chain of custody is very important for forensic. And data collection sometimes will entail file carving, and we can examine RAM, we can examine, history of your systems like browsing history. We can take a look at application and processes that's installed on the system. So data collection would require a lot of time and resource. So that will be the first phase in forensic process. Now, once you collect data, then you would examine the data, and examination would entail cleaning up the data or looking at what's missing on the data, what other sources you can also supplement for the data. Sometimes you have to examine the data twice to validate the data and making sure that the data has integrity. So in the next question, it asks you to describe the task and to be performed by the 4 forensic steps. As we mentioned, data collection, you need to identify where the data is coming from and how to obtain the data. sometime that would require legal permission to access the data and use validated forensic tools. Now, as most of you have taken the forensic class, the forensic tools are most of them are validated through NIST, but you need to also submit your tools for validation if it is not on the list. NIST validated tool doesn't always become validated in court. So you have to go through the validation process and making sure that your tools are verified and validated. And then your procedures are also needs to be validated. So you need to complete the procedures, the same procedures multiple times to make sure that you have accuracy. If you produce the same results, that means that you have accuracy in your data. So obtaining data would require resources and time. And so you need to, number one, identify where that sources are and the tools that you need. The second stage is for data examination. You need to filter data. In security, we need to take a look at event logs and different types of logs for our system, like application error logs or server logs. We sometimes would need to take a look at email messages, email headers, and so on. So your messages are important. So filtering is going to narrow down the specific type of data that you can utilize for your artifacts. And then looking at network capture or network traffic, finding the relevant evidence. And so when you're using something like Wireshark, you can definitely apply the filter fields in how you want to take a look at the certain type of packets and the nature of the packets, the timestamp, the source, the ports. All of those things are important for data examination. Then the third stage is to do data analysis. This is when you interpret and analyze the data for correlation. In the case that if we're looking at infected traffic in the network based on a malware incident, we want to correlate that to the nature of the malware. If it's coming in for the payloads, the size of the payloads, how that payloads is entering a certain destination or target a certain destination like the system. And with Wireshark, you're able to extract or export out that particular payload and examine that in a sandbox where you would be able to see the nature or the malicious activity that that malware is committed or created to achieve. So with that, we would be able to see the patterns. We can use automated tools or even manual detection for the indicators for analysis. And lastly, for reporting in evidence, we want to formulate the reports. And this is going to be also for business response for PR matters in the organizations, externally, and then also internally, we want to communicate with the employees and the staff. And then sometime that will also lead to reporting to law enforcement, executive and management, and then your stakeholders. Now, in forensic, chain of custody is important. So for question 15, it asks you to describe the chain of custody procedure in data or digital forensic. So first, chain of custody is applied at the beginning stage of evidence collection. So in the first stage, which we covered in the last question, in data collection is when you begin the chain of custody. We need to document relevant information. That means that we would need to take photo. We would need to put down informations like model number, physical descriptions, logical description. For example, if we're looking at drives, we need to make sure that we put down sector size, or even like the clusters on the drives, and where we obtain the drive, which system has the drive attached, and so on. So we want to document relevant information on where and how the evidence is obtained. And in the case where the evidence changed hands from one specialist to the other, or passing to different offices, it's important to document the evidence and record the detailed transaction. So for question 16, I want you to visit this link, and it's going to take you to the guidelines for evidence collection and archiving. This is provided by the Internet Task Force. It tells you on how you would be able to obtain evidence for forensic purposes. If you go down a few pages, you would get to section 2.1. This is when you would find order of volatility. And in forensic, we follow the order of volatility based on we would examine from the highest volatility to the least volatility, because in the case that if we lose power, right, your system state change. So in this section, it says, when collecting evidence, you should proceed from the volatile to the less volatile. That means that we would start with something from register to cache, and this is temporary storage within processor. Then we can move to routing table, ARP cache, process table, kernel statistic memory. And a lot of this resides in RAM of the system. So routing table is on the RAM of the router. ARP cache is the system RAM, so it stores that temporarily for ARP. And ARP just basically associates your physical address to your IP address. And then your process table, in Windows PC, we would see this with the performance monitor, along with if you are using PS in Linux system, you should be able to see your process table. And so this exists on the RAM. Then we will move into temporary file system, then disk, remote logging, and then physical configuration, network topology, and archival media. So in this question, I had put down that when collecting evidence, forensic examiners should proceed from volatile to the less volatile, such as registers, cache, routing table, ARP cache, process table, kernel statistic, memory, temporary file systems, disk, remote logging, monitoring data that is relevant to the system in question, physical configuration, network topology, and archival media. And in some cases, you might also look at RAM for crash dump, along with various things that would be important. Um, in the case of malware, you also need to look at RAM as well, or temporary storage, because the process for malware, it loads that into the RAM. So you would see that there are there are multiple processes that would be overlapping or concurrently running. So examining volatility, the order of volatility in forensic examination is very important. And then 17, how can you preserve forensic evidence? In preservation, we want to make sure that our data has integrity. That means that hashing your files and images here refer to system images, capture of the entire system with its applications and processes running. So we need to make sure that we create hashes for the files and the images. And when you're using forensic toolkits or application like DD to create your images, it has a feature to integrate that it uses hash to build out your image. So as you create the image, you will be able to tell it to generate a certain type of hash, like SHA-256 or SHA-256 or 512, etc. And so this is going to allow you to use the value for the hash value for checksum. We want to make sure that we validate our image. That means that our image is not changed over times. In the case that even if we examine using forensic tool does not change the nature of the actual image. But if you open up the system and open up files, that changes the nature of the system. And then logs, we need to make sure that it's stored with the right once read many or WORM to make sure that we preserve the evidence. You can also use write block in the case that if you're examining drives. And so for this part, um, you can refer to, and also for chain of custody, you can use the standard form, which is shown on page 11, but some organization would have their own customized form. There are templates for these type of forms that you can use. Um, and we refer to RFC 3227 for order of volatility. Now, for memory snapshots, you can create memory snapshots using applications of forensic tools. These memory snapshot is often created as a VMEM file, VMEM, and that allows you to examine just the memory storage and sometimes the logs for those storage. The next part here talk about cryptanalysis in the case if you have something like ransomware that would require cryptanalysis. And so this is going to be a procedure that you need to implement or the technique that you need to implement to be able to examine the ransomware attack. So the purpose of steg analysis, so when you have something that's embedded or hidden into a file, like an image file, simply distorting the file, so it modified the bits in for the JPEG or the PNG. By modifying the bit, they can embed some text into the file, and that's called steganography. The purpose of stegananalysis is to really discover or find the hidden data or the payload inside those files. You can use various tools for that. And I think in this textbook, they mentioned some of the tools in the later part, but stegananalysis tools are commonly integrated with some of the forensic toolkits like FTK or even Paladin. And then the last part of the notes, it breaks down some of the various common tools such as file carving tools and some of the other tools. So that would address our last questions. Number 19, identify and briefly describe the functionality of some of the forensic tool. And you're not limited to these tools. There are other tools that the industry use, commercial or open source. But these are the recommended tools from your textbook. Number 1, this category is for file carving tool. You can use file carving tools such as Foremost. Foremost was used in one of my course for, to be able to retrieve file types. So this tool is going to allow you to retrieve some file types, especially deleted files, and it's examined the file system, such as if you're looking at Windows, that would be NTFS or FAT. And then in Linux, it will be X4. And the second tool listed would be strings. This allows you to search the image file or the memory dump for ASCII or Unicode strings like text. This is integrated in tools like Autopsy, where you can do keyword search or search with text, whether you're working with a DD image or an EO1 image. It allows you to be able to do a string search. Second category of the tools is the binary analysis tool. Binary analysis tools, bin files are created through the compiling process. And so a lot of the tools that would examine the bin files would require reverse engineering. So you would have something like hexdump which allows you to capture and analyze the data for specifically for flash memory. But if you use binwalk is allowing you to search bin images, binary images for embedded files or executable code. GIDRA in particular allows you to do reverse engineering for compile code, but there are other tools outside of GIDRA for that. And then LDD, this allows you to display the dependencies for the binary files, as some binary files would require dependencies to compile for that particular software or script or code. Analysis tool, you see EXIF tool. EXIF is a common type of tool. This allows you to examine metadata. EXIF is built into forensic toolkit like ProDiscover, Autopsy, FTK, etc. So whenever that you see a forensic toolkit that allows you to pull pictures or images and be able to examine metadata for those pictures and images, it has EXIF tool incorporated. But as a tool on its own, you'll be able to install the package to be able to do that. Sometime you need to perform live or wireless based analysis. And Aircrack NG is a popular tool that allows you to monitor wireless traffic along with performing encryption attack on the wireless networks. And sometime in the case that we need to be able to crack a certain encryption for a specific wireless device, that will be Aircrack NG. Volatility is very common. This is command line based. It has its CLI, works in Linux, Windows, and Mac OS, but it uses command line based structure. So it allows you to examine memory resident artifacts. Specifically, if you examine files like vmem or memory snapshot, you can also examine hibernation file and VM snapshot or crash dump to look at processes, to look at information on that particular system, especially storage related to memory. Then you have the next category, which is imaging tools. These tools allows you to create system images. That means operating system applications and a process within. We would use things like FTK Imager, that is part of the FTK suite. You can create images that is standard, such as E01, Smart NDD, which is raw. You can also use DD, which is Linux command line based distribution, or Linux distribution command line based for creating your disk dump, or basically an image of your disk. It is a good way to also use it for data duplication. You can also use things like Autopsy, ProDiscover. They all have imaging tools. And in my forensic class, right, we have used Autopsy to create images from USB to drives to be able to utilize that image for examination. Then you have hash tools. These are to create hash for integrity or checksum purposes. Hash tools are integrated with operating systems nowadays, so you can use Windows, Linux, or even Mac OS tools to be able to implement hash algorithm. So things like SHA, SHA, with a certain key length like 256, 512, etc. with the sum. This allows you to calculate checksum for a file. And then SSDeep, this is used for fuzzing hash. It's allowing you to identify how similar your file to the other file. So SSD does the file comparison based on hash algorithm. And then for the live collection tools, for the network, we can use NetStat. This provides you with statistic for the network, such as what port is listening, what port is used for connection, IP addresses, whether the connection is local or remote, is it established or stale. We can also use tool like PS in Linux. This allows you to look at running processes. It will provide you with process ID and the order of the processes inside the process table. VMstat, this tool is to display the number of computing resources that's currently used for the resources, similar to what you've seen in Task Manager and Performance Manager in Windows environment. LSOF or LSOF, this is going to allow you to list all open files. This is useful when you're looking at if you're investigating a user that's accessing various folders or directories or files within a certain system. Contract, CONNTATRACK, contract, this allows you to view the details in the IP table, particularly the firewall IP tables or the state firewall. This is gonna let you examine the update for the IP table in the firewall, whether for the rules for filtering purposes, if you're examining how the attack comes in through the firewall. Then you have Wireshark, which is a network sniffer. This allows you to capture network traffic in real time. It also allows you to view a recorded capture, examine it, follow a certain composition for the systems, even export files from a certain packet. In the case if you're looking at malware infected traffic, you can use network sniffer like Wireshark. And this concludes the assignments for Unit 7, which is Chapter 8. I recommend that you look through the notes a little bit closer, go through the description of the tools and the details of the concepts, examples that's provided in the notes. This is important for certifications and also our quiz and exam. I didn't include all of the tools that are listed in the notes. However, there are useful tools like ELF and other tools that you would see there. So in the case that if you need to refer to it for forensic purposes or incident response, it's helpful that you know which tools are available. And I would recommend that you read the documentation for the tools before using it. There are requirements in the installation for the tools and instructions on how to utilize the tool. Because once you launch the tools and use it, if you don't do it appropriately, you might change the timestamp or the state of that system. So making sure that you understand how to use the tool before approaching it is important. And please let me know if you have any questions, and thank you for watching the video.